Good morning. So today we are going to discuss a new topic, and that is the texture of sedimentary rocks. Generally, in the texture of sedimentary rocks, we will discuss the texture of clastic sedimentary rock. We all know that clasts are nothing but they are the derived sediments from the pre-existing rocks. They are also known as detrital, and the clastic or detrital, they are also known as terrigenous. So we will discuss the texture of clastic sedimentary rock, that is also known as texture of detrital sedimentary rocks, that is also known as texture of terrigenous sedimentary rock. So all these terms, the clastic sedimentary rock, the detrital sedimentary rock, and terrigenous sedimentary rocks, generally they are synonym. Texture basically refers to the size of the sediments, the shape of the sediments, and the arrangement of the sediments in a sedimentary rock. In sedimentary rock, the sediments, they are very, very important. The sediments are derived from the pre-existing rocks by the process of weathering. It means there are detrital or clastic sedimentary rocks. There are sedimentary rocks which are formed by chemical processes also, the carbonates. There are sedimentary rocks which are formed by the sediments which are formed by the process of evaporation also, vaporites. Then there are sediments which are formed by the volcanic activity also. They are known as volcanoclastic sediments. In the texture of sedimentary rocks, there are three important parameters: the grain size of the sediments, then shape of the sediments, and then the arrangement of the sediments or the grains. The size of the sediment is an independent topic itself, and that is known as the analysis of the size of the sediments in sedimentary rock. Mainly clastic sedimentary rock is known as granulometric analysis, and this is very important topic in a sedimentary rock, because the sedimentary rocks are derived from sediments, and then it is very important to know the size of the sediment in a clastic sedimentary rock, in a terrigenous sedimentary rock, in a detrital sedimentary rock. And the size of the sediment is, the determination of the size of sediment is known as granulometric analysis. So in the texture, number one is grain size, second is grain shape, and third is arrangement of the grains. Grain size, that is the MZ, mean grain size, which we will discuss later on, today itself, that is the granulometric analysis. Then I am coming directly to the grain shape. The shape of the grain, that is either roundness or that is sphericity. This is the most common term used in clastic sedimentary rock, roundness and sphericity. Sometimes we use this shape as equant if all the different axes of the grains are roughly equal. Sometimes we use the term tabular if two sizes are equal. Then prismatic, oblate, all these terms are used for the shape of the sediments. Then the roundness and sphericity. Sphericity is that parameter of a sediment which explains that how much a sediment is close to become a sphere. For example, in this sphericity is high and in this the sphericity is low. Again, in this sphericity is very high and in this sphericity is low. So sphericity is that parameter of any sediments which indicates that how much that sediment is close to become a sphere. Then the roundness is another property of a sediment which indicates the removal of the angularity of the corners. If they are removed, then this is rounded. This is angular. If the angularity of the corner is removed, then this is rounded. This is angular, and if the angularity of the corner is removed, this is rounded. So this is well rounded because there is no angularity at all in the grain, and this is sub-rounded, and this grain is angular because all corners are angular. So how this angularity of a sediment is removed? The angularity is removed by the process of weathering, and it indicates the degree of transportation of the sediments. It means the well-rounded sediments, they indicate high degree of transportation from their place of weathering to their place of deposition, whereas angular grains, they indicate low degree of transportation. It means the sediments were deposited very close to the place where they were originated. So the well-rounded and the angular sediments, they explains the degree of transportation of the sediments from their place of weathering to their place of deposition. Then the third point is the arrangement of grains. In this, number one is the imbricate structure. If this is the direction of the movement of the current, if the grains, they are aligned like this. All the grains, they are lying above each other, and this, the vertical axis is aligned perpendicular to the direction of the movement of the current, and the imbricate structures in which the boulders or the clasps, they are aligned in a different direction. They can be used for the identification of the paleocurrent direction of the river or any depositional environment which deposited that particular rock. Then the second is the packing of the grain in the arrangement of the grains. How the grains, they are packed. If all the grains, they are in contact with each other, this is known as class supported, and if in between the grains there are finer sediments, then this is known as matrix supported. So the class supported grain and the matrix supported grain, they are also very, very important. Then the third is that what is the maturity of the rock. There are two types of maturity. One is known as textural maturity and another is known as compositional maturity. Textural maturity, it is directly related with the salting. It is directly related with the percentage of the matrix in the rock. The rock is said to be texturally mature if the percentage of the finer size sediments or the matrix or the clay in the rock is almost negligible. Then the rock is said to be texturally mature. And if the percentage of the fine grained sediments or if the percentage of matrix or the percentage of the clay is high, then the rock is said to be texturally immature. In compositional maturity, it indicates the percentage of the stable clast or stable grains or stable sediments. And it depends on the percentage of the quartz, because quartz is the most common mineral of clastic sedimentary rock, or we can say that sandstone or terrigenous sedimentary rock. So if the percentage of the quartz is high, then the rock is said to be compositionally mature, and if the percentage of the quartz is low, then the rock is said to be compositionally immature. In the case of non-clastic sedimentary rock or carbonate rocks, there are two more terms: oolites, pisolites, and pallets. Oolites are less than 2 mm in diameter. Pisolites are greater than 2 mm in diameter. Pallets are again less than 2 mm in diameter. They are circular, semicircular, oval, semi-oval, spherical, semi-spherical, elliptical or sub-elliptical in shape. So the shape of oolite and pallets and pisolites are almost similar. Means that is circular, spherical, elliptical or oval. But the pisolites are greater than 2 mm in diameter, whereas the oolites are less than 2 mm in diameter. The only difference between oolites and pallets is that in pallets there are no any internal structure, whereas the oolites, they are characterized either by this concentric structure, internal structure, or like this, the radial internal structure. They are very common oolites and pallets in carbonate or in non-clastic sedimentary rock. Then the first point of the texture of clastic sedimentary rock is grain size. In A, we can see that the size of the sediment is large. They are coarser sediments. In B, the size of the sediment is small. And in C, the size of the sediment is very fine. It explains a number of things related with the depositional environment in a sedimentary rock. If the size of the sediment is coarse, means the energy of the depositional environment was high. If the size of the sediment is intermediate, the energy of the depositional environment was medium. And if the size of the sediment is very fine, it explains the low energy of the depositional environment in a sedimentary rock. So size is very important parameter which explains, number one, about the energy of the depositional environment. Second, when we will discuss different parameters of the grain size, then we will study one more term, that is sorting, and that explains the energy consistency, that the energy of the depositional environment was consistent for a long period of time, or the energy of the depositional environment was fluctuating. So this is very important parameter in a clastic sedimentary rock, and that is the grain size, and its analysis is known as granulometric analysis. So for the first time, the size of the sediment was proposed by Odin. Later on, it was modified by Wentworth. And the grain size scale is known as Wentworth scale. This is also sometimes known as Odin-Wentworth scale. In the Odin-Wentworth scale, this is a millimeter scale. From less than 1 by 256 millimeter in diameter is the size of clay. 1 by 16 to 1 by 256 millimeter in diameter, that is the size of silt. 2 millimeter to 1 by 16 millimeter in diameter, that is the size of sand. Greater than 2 is gravel. then 2 to 64 is pebble, 64 to 256 is cobble, and greater than 256 millimeter in diameter is known as boulder. So this is the size of the sediment according to the Arden-Wentworth scale. Then, because it is very complicated, 1 by 16 to 1 by 256 is this size of silt. So during granulometric analysis, the multiplication and the division that becomes very complicated. So to remove this complication, later on this scale was modified by Crumbine. The Arden proposed the Wentworth scale in 1914. Wentworth he proposed in 1922. The Crumbine he proposed the scale in 1932. The Crumbine scale is the phi scale. And according to this, the side of the sediment in phi is equal to minus log Wentworth scale at the base 2. This is the formula, that the side of the sediment in phi scale is equal to negative logarithmic of Wentworth scale at the base 2 or millimeter scale at the base 2. This negative sign is used because generally on the probability curve the size decreases from left to right. In this direction size decreases, and that's why generally on this scale any number that increases from left to right, but in the grain size analysis the size decreases from left to right on the probability curve. That's why we use the term negative in the Crumbine scale. And in the Crumbine scale, 4 to 8.5 is the silt, 8.5 to 9.5 to 10.5 is the size of clay, 4.5 minus 1 to 4.5 is the size of sand, then coarser than minus 1 is the gravel. This is the Crumbine scale for the size of sediments. We take the bulk sample, if this is the bulk sample. If we have taken this from any river, Ganga river or Gomti river or Great Gandak river or Yamuna river, we have collected the bulk sample. Then we can analyze the size of the sediment with the help of sieving. But nowadays laser particle size analyzer are there in the laboratories, sedimentological laboratories, and directly it can be calculated. But when we were students, we used to analyze with the help of sieves, ASTM, American Standard Test of Materials. So we used to measure the size of the sediments of any river through this shaker and through sieves. So we take the bulk sample and then we analyze. Even in the case of laser particle size analyzer or through sieves, we use the sand and then we calculate the size of the sediments. So how to calculate this grain size? There are many graphs on which we can represent. One is the histogram. This is the interval of the size of the sediments, and then we represent the percentage of each size of the sediments like this. This is known as histogram. Then we represent in frequency curve. In frequency curve again, the interval of the size of the sediments, they are represented, and their percentage in gram is also represented, and then a graphic is prepared. But we use the cumulative frequency curve. Cumulative frequency curve for the measurement of grain size, standard deviation, kurtosis, and the skewness. And this is the probability graph paper. You can see that this indicates the number of cumulative weight percentage, and this indicates the diameter in 5 units. This is -5 means for coarser sediments, this is +10 means finer sediments, and this is the direction of the increase of cumulative percentage of the sediments. And there are a number of formula. That formula was proposed by Folk and Ward, and according to that formula we can calculate the MZ, that is the mean size. Then we can calculate the standard deviation. This standard deviation is also known as sorting. Then we calculate the skewness, and the fourth is kurtosis. We have already discussed about the grain size, the sand, silt, clay, pebble, and the boulder. Then the second point is the standard deviation, that is also known as sorting. Sorting is very important parameter in a clastic sedimentary rock. There are 3 figures, A, B, and C. C, A, and B. In the case of A, all the size of the sediments are roughly equal. The energy is high. In case of B, all the size of the sediments are roughly equal and the energy is low. But in the case of C, the size of the sediments is unequal. Some are coarser, some are finer, some are intermediate. So energy is fluctuating. In this, all the variation in the size of segment is very low, so sorting is very good, they are well sorted. In this, no doubt the energy is low, but the variation in the size of the segment is very low, so they are also well sorted. In this, the energy is fluctuating, sometimes very high, sometimes very low, and they are known as poorly sorted. It means well sorted grains, they indicate the consistency of the energy of the depositional environment, whereas the poorly sorted grains, they indicate the fluctuation in the energy. It means if we are getting poorly sorted sediment, which explains that the energy of the depositional environment was not consistent for long period of time, the energy was continuously fluctuating. Whereas the well sorted grains, they explains that the energy of the depositional environment was consistent for the long period of time during the deposition of that particular rock type, and the energy was not fluctuating. So this explains the consistency of the energy well sorted grains, and the poorly sorted grains, they explains that the energy is continuously fluctuating. So this is the importance of sorting, that indicates or explains the fluctuation in the energy level of the depositional environment. Then third point is skewness. Skewness is that property which explains that the grains, they are normal like this. If it is like this, then they are normal. But if this is the graph, in this direction we are getting the coarser grains, in this direction we are getting the finer grains. In the probability graph paper we have already seen, left side is coarser and the right side is for finer segments. So if it is like this, if it is skewed towards negative direction, means the coarser sediments are in excess. If it is skewed towards positive direction, means the finer sediments are in excess. So skewness indicates that the rock is skewed towards coarser sediments or towards finer sediments. Then the fourth one is kurtosis. Kurtosis explains the thickness of the curve. If it is like this, then this is known as platykultic. And if the graph is like this is known as leptikultic. This explains that the tails, they are better sorted than the central part. Whereas if the peak is in the central part, it means the central part or the middle sized sediments, they are well sorted or more sorted than the coarser sediments and the finer sediments. So there are four things in the granulometric analysis. Number one is grain size, second is sorting, third is skewness, and fourth is kurtosis. And all these four things are very, very important in texture of a sedimentary rock as well as in the granulometric analysis. I am very, very thankful to all the students and all the viewers that during this lockdown period, even with limited resources, we are trying to our best to understand the basic concepts of sedimentology and sequence stratigraphy. In the next lecture, I will explain another very important topic of sedimentology. Thank you and good wishes to all of you.